YouTube channel. Now this video is a continuation from my part 3 of my previous Form 5 Chapter 2 Electricity, where I've stopped to parallel and series circuit, and what you will see on the left page here is actually it tells you on how to actually get this fraction of it's actually a fraction how many of the total by taken out by the voltage. So I mean we have a circuit that's look like, you know, this is the voltage you get from the cell, and then this is in series. So you get 1, 2. So I think it's easier to say, oh, okay, can you give us some value? It's so much easier. Okay, let's talk about 12 volt. What you get across here, 12 volt. And say for example, here is 2 ohm, and here would be 4 ohm. So what would be your V1? Okay, but normally, conventional way in the past, you will say, oh, okay, you sum up because series sum up is 6 ohm. Okay, 6 ohm. Then eventually the current is 2 ampere. Then from 2 ampere, then you times V equals IR. 2 is 4. Then you thought, oh, it's 4 volt, right? This is what you have taught in the past. But now, to give you another perspective, I mean, another way to look at it is you look at how many percent, how many part of the total. So therefore, your V1 is actually, you want to look at V1 here is only 2 ampere out of total 6 ampere times voltage, terminal voltage 12 volt, and this is where you can get your 4 volt, right? Like how you get. But if you use the previous method, you find out what's the current, and then from the current you times with the resistance, then you are taking much more time that you need to in order to solve objective question. So that's the reason to why this equation is important. It says, it tells you the fraction, how many out of the total here. 2 out of 6 for the total 12. It's like a percentage. Okay. All right. That's what we have stopped in my previous video. Then this time round, I will talk about EMF, electromotive force. Okay. So what does it mean? Okay. It's actually the battery part. Okay. It's more on the battery part. So I'm going to sketch actually a cell. Cell is only one battery. Okay, a cell, enlarge it. This is the ordinary cell that you have of any brand. So what happened is a cell is actually made from chemical energy, electrochemical cell. Okay, where we denote by, this is the actual electrochemical cell inside. Or okay, since you need a cell, better way is I only draw one pair. So this is a positive terminal, so I have positive, negative. Now what happened is, when you have this chemical, you have learned in chemistry, I hope you were able to relate them, the chemical reaction, when ion and cation moves around in between the cell, what happened? They are going to have friction, and this friction contributes to this called internal resistance before it really comes out. Okay, from your cell, where you're going to label this as a positive terminal, and this is negative terminal. Okay, so therefore, in our actual case, you have internal resistance small r. Okay, so what we normally get where you connect it to a light bulb in a closed circuit closed-up circuit in the light bulb, and then of course it will light. You have your light source, okay, where you have your chemical energy to electrical energy, and then you have light and heat energy. That's how the energy flow. Okay, so if you were to attach a voltmeter, which is supposed to be parallel, okay, the voltmeter, you get the voltage drop, or perhaps the potential difference from here, this point to this point, will be the same, where this voltage is a name. There's a name for it. They call terminal potential difference. This is at the terminal. Terminal potential difference. Symbol VT. Okay. Then how about the one here? They're going to voltage drop from here to here. Okay. Inside the cell, okay, you can't really see it. You can't really put an ammeter or a voltmeter across it. So the one here, it's called voltage drop. Okay, where V small d drop. Okay, it's a work done by the force, by the source, during one coulomb charge through the cell. It's inside the cell. Okay. Then the one here is defined as, is called the EMF, electromotive force. Okay. Electromotive force. F. Oh, sorry. E. Okay. It's actually I mean, the definition is quite the same. It's just that it's work done. Electromotive force, EMF. Sorry, EMF. Okay, it's a work done by the source in driving 1 coulomb of charge, positive and negative, okay, charge, around external circuit. So how they are related? So they are actually like a series, is in a series configuration. How is that so? Because E, electromotive force, EMF, is actually VT, potential difference, plus your voltage drop. Okay, and in some book or reference, they rewrite this as E equals to, because the current is the same, amount of electron that pass through here, and the internal resistance is the same. So therefore, there will be I. This is R external plus R smaller r. This is the internal resistance. Okay, that's basically all about this EMF. This is the two equation. Actually, there is no two equation. It's only one equation. From here, this is the thing that you need to know. The rest is a derivation. It's just derived from that. Current is the same, and then that's where your internal resistance comes in. Okay, so before we proceed to the next sector, I mean the next topic. Not a new chapter, but there's one last one. It's called power rating. Maybe I'll give an example just in case in the previous, because it's important, yeah, on the series and the parallel circuit. Maybe I will give you an example of number instead of so many symbols. I know that this symbol is you're not familiar with it, but you really need to understand those symbols before you can really solve it, because from the symbol you get to understand what's happening. Okay, so with me here, there is a combination of a parallel and a series circuit. Okay, this is one of those typical questions. Okay, and here is 2 ohm. Here is also 2 ohm. Over here, maybe it's 8 ohm. Then you will inform that you have 6 volt with internal resistance about 1 ohm. Okay. You were asked to find out what is the voltage here. Okay, what would it be? What would this reading? Okay, now whenever you come out of this kind of question, the thumbs up rule would be to simplify this circuit into one resistor only. So one way is you simplify this. Okay, then from this is parallel. So parallel, that will be 1 over RT is 1 over 2 plus 1 over 2. It happens to be 1, so therefore your total resistor is 1 ohm. Then here is 1 ohm, here is 8 ohm, here is 1 ohm internal resistance. Therefore you simplify this. You need to really do it really fast. Because objective question, you don't spend more than 2 minutes. So 1, 9, 10 ohm. So therefore the current will be V equals to IR. So your I would be 6 over 10 ampere. Therefore your I is actually 0.6 ampere. Now if I comes out is 0.6, is split here, union here, 0.6, 0.6, 8 ohm. So therefore your V would be equal to IR, 0.6 times 8 ohm. Therefore your voltage reading are supposed to be 4.8 volt. Okay, so this is how you need to solve it. The thumbs up rule is you simplify this complex circuit into one simple circuit. You call it effective resistance, whatever you call it. Simplify it, and then you find out what's the current. Yeah. So there are a few layers here. I thought you may want to pause this video and get something from here. I hope you really have indeed try at least 20 questions in past week. In the last week, I think I advise you guys to really go through the reference and try at least 15 to 20 questions in my past video towards the end. So I hope you really have tried. If you haven't finished doing so, I think it's good that you spend the future week, 1 week, to really go down to this kind of question with internal resistance, because sometimes I find that student tends to forget about this internal resistance. Yeah, you need to sum here, and also sum here. Right? So that's the part for circuit. So next, it will be called power rating. power rating, what does it tell? Power rating is actually the energy. Okay, we call it energy. Energy release per second. I mean, how fast or how capable is a machine to release energy in 1 second? Okay, power, symbol P, is actually work done over time taken. I mean, time taken to complete the work. So that will be equals to P equals to E over T, or rate change of work done, or rate change of energy exchange. Okay? Alright? Now, from here, this is the definition. Rate change of work done. Rate of change of work done. Or another way to interpret this would be from the concept of, I mean, the common symbol or common quantity here is actually energy. We do energy with this chapter is when we have voltage, right? What is voltage or potential difference? Potential difference is work done per unit charge. Okay, the symbol might be different, or the capability of do work is energy, right? So capability of energy, so energy over charge, so that it will be synchronized this symbol. Okay, capability to do work is actually caused by energy, possess energy. So make use of this symbol. So what happened is you rearrange them. Therefore, energy is equals to Q E V. Is not new equation, it's just a derivation. Okay, QE. And what is Q? Q is equals to IT. Okay, so I want to get how you derive this equation, how you get this power. Okay, equation. So rate change of work done, so E over T, right? So that's where I get my T. So you bring it down, you divide both sides with T, so therefore your E over T will be IV. Rate change of energy, so therefore power is also equals to IV, current voltage, where the unit for power is watt. Or is that all? No, I think that's basically about it. So you see there are actually two variants of it, then how I'm going to make do with it. Okay, you don't actually substitute into here because actually it's actually the same thing. So what you can do from Ohm's law, V equals to IR. Because of this, you may modify this equation further. You may substitute V, so therefore your P power equals to I squared R. Okay, so this is when you have a cable and you have current flow through it. The heat loss inside cable is because of this I squared R. Okay, in some question where you doesn't know what is current, then you substitute this one into I into substitute I, and therefore you get P equals to V squared over R. This is a time where you doesn't know what is I. So you really need to not memorize, no point you memorize it, but you need to really know this equation and this equation. And as you have tried all those objective questions, after many questions, these two equations will become so common until you just recall it out from nowhere. P equals I squared R. This is a time where you don't know what is V. P equals to V squared over R when you have no idea what is current. But where does it come from? These two equation comes from here and here. And where does V come from? V come from actually here. Okay, it's easy to look at my video, but it's hard when it comes to have question. So it's always my advice in all my video, you really need to sit down there in a week time. You try at least 20 questions, objective questions. Otherwise, there's no way for you to solve any kind of question during your SPM by the end of the year. Okay. Before I stop this video, in some power questions, sometimes they will have there are times they ask for efficiency. Okay, efficiency of appliance. Okay, so efficiency symbol eta, pronounced as I-T-A, eta. Okay, N with a long tail. So efficiency is actually the power output over power input times 100%. That's all about it. What does it mean by that? You have a machine, your input power, this is P input. How many do you get out from this machine? Okay? Say for example, you have a machine or a motor. The power input from electricity so much. When it do work, rotate, and you get the energy per unit time is so much. And then what's the efficiency? It says is let's say 10 watt. What does it mean by 10 watt? Okay, 10 watt, it means in 1 second is capable to do or lift 10 joule of load. Okay, in every 1 second, 10 joule of load. This is what it means by 10 watt. Okay. I think that's basically, I think that's all about it. I mean, it's some add-on notes. Most important part is the work done per unit time, energy per T, and then how I'm going to get this equation is from voltage. Voltage is energy per unit charge. Okay, where do you get this? You get it from my previous 2 video. And I really do like the thumbs up button or the like button. Kindly press on the thumbs up button, it means you like it. And if this is your first time watching my video, kindly subscribe to my video for more upcoming new videos. Okay, thank you.